On the FE exam, you are going to need to be able to tell somebody the roots of a given polynomial. And to go back a step and remember what roots are, roots, if we were to look at the function f of x evaluated at x, roots are simply the values of x at which f of x is equal to 0. And so in this generic polynomial I've drawn here, what we see is that we have 3 roots. And another thing to remember about polynomials is that the number of roots you will have a maximum number of that degree of the polynomial. So if we're dealing with a 3rd degree polynomial, we're going to have a maximum of 3 roots. Now, if I were to shift this polynomial high enough up such that this part of the graph never touched the y-axis, then this polynomial would only have 1 root. So there's no hard and fast rule for necessarily how many roots your nth degree polynomial will have, but you can bound it by a maximum value, and that is n, which is the degree of that polynomial. And so moving forward with the roots of this polynomial, what we're going to note here is that we're seeing, first of all, we've got an x cubed term, so we're thinking 3rd degree polynomial, but we do have a 1st degree polynomial in our denominator, so the overall polynomial here is really a 2nd degree polynomial, so we would expect a maximum of 2 roots. And another thing that I find very useful for when you're dividing polynomials like this is a trick that we hopefully did in algebra, which is if we look at the coefficients in terms of each degree in our polynomial, we can very rapidly determine if a root, if something is a root, and if it is a root, what the new polynomial will be after you've pulled out that term from it. And so what I mean by that is, if we look here at this polynomial, our terms are all positive, +1, +6, +11, and +6. If I write them out like this, 1, 6, 11, 6, and if I wanted to see or guess if x plus 3 was a factor of this polynomial, which is another way of saying x equals -3 is a root, because this term in our denominator indicates that -3 is a root. If we plug it in like this, -3, and then we do the following where we say that we pull down our first coefficient regardless of what it is. So in this case we'll have 1. We're going to multiply this coefficient by what we're guessing our root is. In this case it's -3. So we're going to have +1 times -3 equals -3, and then you're simply going to add down these terms. So we're going to have 6 plus -3, and that is equivalent to +3. We're going to have -3 times +3, which will be equal to -9, and then 11 plus -9 is equivalent to +2, and then let me just draw out these arrows to make it a little more clear, and we're going to have +2 times -3, and this is simply equal to -6, and then +6 plus -6 is equal to 0. And so what this tells us is that because we have a remainder of 0 right here after we performed these steps, is that x equals -3 is indeed a root of our numerator right here. And so what that tells us is that x cubed plus 6x squared plus 11x plus 6 is equivalent to x plus 3, which is what this -3 refers to, and then times the quadratic, or the 2nd degree polynomial, of 1 times x squared plus, and then 3 times x, and then plus 2. So hopefully we can see where these coefficients are coming from. And so this is very nice for us because it's a quadratic. We can very readily decompose it. So we would have x plus 3, and then x plus 2 times x plus 1. And what that tells us is that because we did have x plus 3 in our denominator here, these terms will cancel out, And so this overall term is really just x plus 2 times x plus 1, and the roots would be x equals minus 2 and x equals minus 1. And so that is how we determine the roots of our polynomial. And so it is very important to keep track of the degree of the overall polynomial by looking at the degree of the numerator and denominator, and then by also using this nice algebra trick that we hopefully learned back in high school. And so that is how we are going to determine roots of polynomials. The next thing that I'd like to work on is how we determine the intersection point of two lines. So if I was to give you line 1, which is x minus y equals 0, and line 2, which is 2x plus y equals 1, and I wanted you to tell me the point of intersection, how are you going to do it? And so the very first step you would do in this case is substitution. And so what that means is if I look at equation 1 here, it means that x equals y. If I simply add y to the right side of this equation, I can now see that x equals y. So everywhere I see a y in equation 2, I can plug in x. And so what that tells me is that we have 2x plus x equals 1. And now that means that 3x is equal to 1. Therefore, x equals 1/3. And because from equation 1, we know that x equals y, therefore x equals 1/3 and y must also be equal to 1/3. And so what this means is that we have an intersection point at 1/3, 1/3. So if you were to actually plot these lines, x equals y, and then this other line here, we would have them intersect like that. And so this actually isn't accurate. We would have a negative slope, but we have some kind of plot that looks like this. And so this is how we determine points of intersection via substitution. And so this is going to wrap things up for this introduction to the expectations for your abilities in terms of roots of polynomials and intersections of lines on the FE exam. I hope you guys find it useful, and thanks for watching.